All right, good morning, everybody. So today we are going to continue our discussion with matrices. This is actually the last section that we're going to be talking about matrices. And then after this, we're going to have a quiz on the last couple of sections. Um, so this section is chapter 4, section 4. I'm sorry, chapter 7, section 4. And in this section, I'm going to show you how to find the determinant of a square matrix. And it's pretty easy because we're just going to use our calculator. So to find the determinant of a matrix, normally what you would do would be very similar to cross products as you did when you had proportions. So you would multiply this diagonal and you would multiply this diagonal and then you would subtract. That's the math behind finding a determinant. But I'm just going to show you how to do it on a calculator because it's pretty simple. It's even easier than trying to do it by hand. So if we open up our graphing calculator here and we hit second matrix, actually we got to quit out of this screen first. Okay. So we're going to hit second matrix and we're going to go over to edit and we're going to enter in the matrix. You can see we have a 2 by 2 matrix and this 2 by 2 is 2, -3, 1, and 2. Like that. So 2, -3, 1, and 2. So now that I have that in, I can hit second quit and go back to my home screen. Now that we have that matrix in, it's just as simple as telling the calculator to find the determinant. So I'm going to hit second matrix again. I'm going to go over to math though. As I scroll over to math, you can see this first heading that I have right here is DET. And that DET stands for determinant. So we're going to choose determinant, and that's the command. And now we simply have to tell the calculator which matrix to find the determinant of. And so I'm going to hit second matrix again, and we're going to have it find the determinant of matrix A. So I close out my parentheses and hit enter, and you can see that the determinant would be 7. Now, for a 2 by 2 matrix, it's probably faster to just do the multiplication. So if I go back real quick to show you, you do these cross products. So you multiply the major diagonal, and then you multiply the minor diagonal, and then you just subtract those two answers. The major one always comes first, then the minor one. So it's probably faster. Like you can see this B right here. If I did 2 times 2, it's 4. 4 times 1 is 4. So 4 minus 4 is 0. So the determinant of this matrix would be 0. That's probably easier than typing it in your calculator. Even with this one, 0 times 4 is 0, and then 2 times 3 halves would be 3. 0 minus 3 is -3. So this one would be -3. And again, you could type it in your calculator and do it like I showed you for part A if you'd prefer to do that. It does take a little bit longer for 2 by 2s. Now, if the matrices get bigger than 2 by 2s, it is much, much, much easier to use your graphing calculator. I actually don't ever show students how to do anything bigger than a 2 by 2 by hand because it's pretty complicated. Um, so as you can see, we said it was 7. You can see right here we got 7 for A, and for part B it was 0, as I said, and then part C it was -3. Now the determinant of a matrix that is just a 1 by 1 is simply the uh, number itself. So in this case, this is a 1 by 1, and the only element within that matrix is -2. So the determinant of that matrix would also be -2. Um, so, all right, so we're going to fast forward. Okay, so dividing by a matrix. Now, the whole reason why in the last section that we learned about inverses was actually to do this division process. We don't ever actually divide by matrices. It's very similar to the concept of us not dividing by a fraction. We don't divide by fractions. We use keep, change, flip, right? So we keep the first number, we change it from division to multiplication, and then we flip the second fraction over, and so we do multiplication rather than division. This concept of an inverse matrix is the same idea here. So if you look in this equation, AX equals B, To solve for x, you would divide both sides by a. So what you would end up with here is b divided by a. But we don't actually divide matrices. We multiply by their inverse. So if you see this notation right here, it's x equals a inverse times b. So rather than dividing by a, we multiply by the inverse. And so here they ask it to solve the following matrix equations given that a is this, b is this, and c is this. And so the first thing that we're going to do is we need to solve each one of these for x. And I'm going to do that right now to show you how that works. So let me pull up my Notability, and you should be able to see a new one here. If you can bear with me for a second. I'm going to go in here. Let's just erase this. Actually, I can just scroll down. Okay, so let's take this first example. We have ax equals b. So in here we have ax equals b. Now the way we would solve this is we would normally, and this is what I was talking about before, we would just divide by a. But we don't do this type of thing with matrices. So what we actually have to do is we have to multiply both sides of the equation by A inverse. Now, A times A inverse cancels, and you're left with x equals A inverse times B. Now, one thing to keep in mind, you have to have the multiplication in the correct order. You can't put A inverse over here on the x and then A inverse over here on the B. It doesn't work like that. The A inverse has to be right beside the A, and then since it's on the left-hand side of the A inverse over here on the B has to be on the left-hand side of B. So now the way we figure this out, A inverse times B, is we're going to go into our graphing calculator. I'm going to type A in. So we'll go into A, second matrix. Maybe. My calculator's running slow here. Let me clear this out for a second. So second matrix, we'll go into matrix A. It is going to be a 2 by 2. And it's going to be 2, 1, 5, 3, 2, 1, 5, 3. I'm going to go into matrix B, and I'm going to edit that to be a 2 by 2 as well. And it's going to be 1, negative 1, negative 1, 2, 1, negative 1, negative 1, 2. Okay, so 1, negative 1, negative 1, 2. Now I can simply go into the home screen that I've entered A and B in. I'm going to go into the home screen, and I'm going to type this right here, what you see, this A inverse B, into the home screen. So second matrix, I'm going to choose A, make it A inverse actually, and then type multiplication, and then matrix B. And hit enter, and you can see my answer is 4, negative 5, negative 7, 9. And you can see right there, 4, negative 5, negative 7, 9. So let's try another one. Let's try this 2a plus bx equals c. Okay, so we have 2a plus bx equals c. So the first thing we need to do is solve for the matrix x. And the way we're going to do that is we're going to subtract 2a from both sides. That cancels. So we are left with bx equals c minus 2a. And now I need to get rid of this b that is still on the x. So I'm going to multiply it by b inverse, and then I'm going to multiply this thing by b inverse. Notice again, the b inverse is on the left of both parts of the equation. So the b times b inverse goes away, and we're simply left with x equals b inverse times c minus 2a. And so this right here is going to be what we type into our graphing calculator. Now I did not put matrix C in yet, so I need to go into Edit, Go down to C. Going to make that a 2 by 2. And C is 4, -1, -3, 1. So 4, -1, -3, 1. So now that I have A, B, and C in the calculator, I can simply follow what I came up with right here by solving. So second matrix, I'm going to go choose B, and I'm going to make it B inverse, and that is going to multiply matrix C minus 2, and then times matrix A. I messed that up. I want this to be matrix A. So I have, and you can see, B inverse times, then parentheses, C minus 2 times matrix A and close parentheses. Make sure you're typing in the multiplication symbols. The calculator sometimes does not like it if you don't do that. And when you hit enter, you can see it's -13, -11, -13, -8. And if I go to part B right here, you can see that -13, -11, -13, -8. I get exactly what I'm supposed to. So we'll do one more here. Let's look at part C. Part C has the expression -4b minus cx equals A. So -4b minus cx equals A. And once again, we need to solve for x. So the first thing we're going to do is we will add 4b to both sides. This cancels. We are left with -cx equals A plus 4b. And now to solve for x, we need to multiply. Actually, we need to get rid of this negative first. Okay, so I'm going to multiply both sides by -1. And when I do that, I'm going to multiply this side and this side by -1, -1, and that'll cancel out the negatives. So you're left with Cx equals, now the -1 is actually allowed to distribute, so what I would have is -a minus 4b. So that's a scalar, and a scalar is allowed to distribute. Now we need to get rid of the c by multiplying by the inverse of c on both sides, like that. These cancel, and my last expression that I'm left with is x equals c inverse times -a minus 4 times b. And now it's just a matter of, since we already have a, b, and c programmed into our calculator, all we have to do in the home screen is type exactly what you see right here. So we'll start with second matrix C, make it inverse, and then we have times, and then we have, and this is important, you can't just put negative matrix A, you need to write -1 times matrix A minus 4 times matrix B. And then you close out your parentheses like that. Everything is typed in, but you do have to type everything out, as I said. And then you hit enter, and you can see we get -7, -8, -22, -35. When I scroll to part C, -7, -8, -22, -35. So we get the answer. So there you go. So hopefully that made sense. I would like you to complete page 537, 6, 7, 12, 22, 24, and 27, as well as solve these two equations. You need to solve this equation for x and solve this equation for x. These are matrix equations, and the matrices A and B and C are the ones that we just used, so you won't need to put new ones in your calculator. You can just use the ones that I just finished showing you in example 2. So, as always, if you have any questions, feel free to email me. Have a great day.